Ladies and gentlemen, welcome to lesson 2.6, finding the area of a trapezoid. So we're going to be looking at trapezoids. They are quadrilaterals today. As in your notes, you might have these. I'm going to zoom in a little bit. Sorry, the other way. A trapezoid is basically a quadrilateral, so I'm going to write that down. A quadrilateral, so quadrilateral, where only one pair of sides is parallel. And if you take a look down here, we have a trapezoid here. This is what is called an irregular trapezoid. We're going to take a look at the three different types in a moment. But you see we got two parallel sides. Parallel simply means that they are never going to cross. They are just going beside each other and they will never cross. Kind of like train tracks, or kind of, similar like that. They will never cross. So we got A, and we call this one B. So we got our labels A and B. And we also have our height, which will always be perpendicular to our base. Perpendicular means that it makes a 90-degree angle. So there are three different types of these trapezoids as we take a look at these. There's one called the right, and I apologize if this doesn't look like a right straight line here, but basically with it we create a right angle with one of our sides. Okay, so that would be an example of right. Sorry for the drawing. Isosceles, just like in the triangle, isosceles means two of the sides are congruent, and we have the parallel. So we got each of these parts here. I'm going to draw that. We got our height, we got our A and B, we got our A and B, and we got our height. And then our last one, irregular, just like the one up top. Irregular means that we don't have the same side length for these. So we got A, B, and we got our height. And I'm going to call this S1 with a subscript and S2, because we don't know exactly what those lengths are, but I'm just going to label them those. So we have our measurements there for our different types. Please draw them. Use a straight edge when you're drawing these, so that way they look more like a trapezoid and not like some 2-year-old drew them like that guy did. Okay, so part of what we need to be able to do with these is that we need to be able to find the perimeter. Now we know perimeter is the distance around, and so the way we find it is we add all the sides. Add all sides. Now, if I have something like this, it's pretty easy, but sometimes you will see that there is a height that is involved, and it'll give you like the height of this would be 10 meters. Okay, that would be not something you would use for your height, so your perimeter. So you would be doing the outside edges. So what we do to show our work is we add those edges. Just a reminder, this is a quadrilateral. There should only be 4. So 16 plus 13 plus 13 plus 26. I add those all together. 6 and 6, that's 12. Plus 6 more, that's 18. 1, 2, 3, 4, 68. So we get 68 meters. For that, make sure you label. Don't forget. Don't forget. Alright, now here's where things get hairy. We're going to be talking about the area of a trapezoid, and we're going to go into a quick proof here. Imagine for a moment we got A and B, and we have this formula that we get. And so I'm going to flip this one over and move it over. So what do we get when we take two trapezoids and we slide it after we flip it? We get a, ladies and gentlemen, a parallelogram with the lengths A plus B as our base. You see it's A plus B. So that is our base, and this would be our base, and then we have our height. So if you remember, the area of a parallelogram area was equal to base times height. Well, a trapezoid as we see here, we would do, since it is, we would do A plus B. That is going to be our base that we saw over here. Okay, so we're going to be looking at that. That is our base times our height. Now, since it took two of these, we're going to take this area here that we just get with adding A and B, and we divide it by 2. So we end up doing 1/2 times the quantity A plus B times your height. Okay, so that's our formula that we get. There's other ways of proving this, but I found this to be the most common sense one, that we take the sum of the two bases, or the average of the two bases, which is taking A plus B and dividing it by 2. That's how I find an average. Add all the parts, divided by 2, and then I multiply it times the height. Okay, so in your notes, here's what we have. And so let's write our formula for the area of a trapezoid right here. We got 1/2 times the quantity A plus B times your height. And so here's what I get. I'm going to write it here. So A equals, here's how I show my work, 1/2 times A plus B. You're writing these in your notes as we do them together. Times height. Now I put another line and I put in my variables, my values for each variable. So my height A is 8 plus my base B, sorry, it said A and B, times, since this is the same as this is our height, 6 feet. Okay, we usually use this dotted line, but since this is a right trapezoid, we can use both. Alright, so now I start simplifying, and I don't do more than one at a time. So what I do is I bring it down. So I'm going to show this in green. I'm not doing this part yet, so I'm going to bring it down, and I'm not going to do this part yet. I'm going to start out by using PEMDAS and doing the parentheses first. So I end up with 1/2 times the quantity, 8 plus 14, I show that with a caret, and I get 22 times 6. Now I start working on the next part. Now I can do this way. I can do 1/2 times 22, or get 11, or I could do 22 times 6. Because I'm a simple guy, I like to do smaller problems first. So I'll do 1/2 times 22, which is going to be 11, and I'm going to bring this down times 6. So we're going to bring this down. We didn't do anything with it, so we bring it down. Next, I rewrite again. I know this is a lot of writing, but you can do it. I believe in you. So we get 11 times 6, and I end up with 66 feet squared. So let's kind of summarize what we did. We took our formula. We replaced the variables A, B, and H with their values in the trapezoid problem. We got A as our first base, and 8 as our first base, and 14 as our second, A and B, times our height of 6. Then we simplify using PEMDAS, parentheses first, and then simplify by multiplying each once at a time. So we got 1/2 times 22, we got 11 times 6. And we end up with our area of 66 feet squared. So our formula for the area of a trapezoid is 1/2 A plus B times your height.